Chapter 66, Higher Roots and Radical Expressions. The square root of 64 is 8 squared. 8 times 8, one factor of the pair comes out. And this is because 8 squared is 64. The cube root of 64 is one element of a triple that comes out, because 4 cubed is 64. The fourth root, you need 4 factors 3 for 1 to come out. The sixth root, you need 6 2's for 1 to come out, and so on. Note that in general, the nth root of n is equal to the nth root of n factors a. Therefore, 1a comes out. You have the 10th root of a to the 10. You need 10 a's multiplied together for 1a to come out. Examples. Simplify the cube root of negative. Yes, that can be negative for a cube root. 81, a to the 6, b to the 7, c to the 8. I need groups of 3, like 27, like a squared times a squared times a squared, b squared times b squared times b squared times b, c squared times c squared times c squared times c squared. Okay, so you have negative 3 to the power 3 and an extra 3 to make 81. You have 3 groups of a squared, 3 groups of b squared and extra b, 3 groups of c squared and extra c squared. The negative 3 comes out, the a squared comes out, the b squared, the c squared comes out. You're left with 3bc squared. Not that difficult. The fourth root of 81. 81 is 3 to the 4, 3 comes out. A to the 4 times a squared, a to the 4 comes out. B to the 4, b cubed, b to the 4 comes out. C squared squared comes out. Quantity to the 9 is quantity squared to the power 4, and then one quantity left by itself. So this will come out as x minus 9 quantity squared. And you do not need absolute values here because a cube, you do need absolute values because that's the fourth root. Third root, you didn't need absolute values. Okay. So b to the 7 would not be defined if b were a negative number, because you can never raise a real number to the power 4 and get a negative radicand. How about this one? You have the fifth root, so make that a to the 20. Make that quantity to the 20. As a matter of fact, you can simplify. Yeah, you could divide by a to the 9. You could divide by b plus 4 to the 6 right here. And you factor out, you have a to the 15, which is 5a cubes, and b to the 15, you have 5 quantity cubes, and the fifth root of quantity to the 5th comes out. Okay, you need 5 of these to come out. You need 5 of these, which you have, for one of them to come out, one factor. How about this one? This is a cube root, all that stays inside. 32 is 16 times 2, so the 16 comes out. 2 to the 4 comes out of here. 8 to the 4 comes out here. 8 to the 4 comes out here. And you are left with a single 2 that was cube root. This is just copied. This is 16 times 2. 16 comes out as a single 2. A comes out as a single a. The a squared is left inside. The 2 is left inside. This comes out as a 2. That's a fifth root. The others were third, fourth, and fifth. So a to the 5 all comes out as just a. This 5 is not an exponent of a. It means the fifth root. Be careful where you put the 5. If you put it too far to the left, it will be confusing. So you have 2. A to the 5 comes out, and the a squared remains inside. What can you do here? Not too much. You can't even combine these two because one is a fourth root, one is a fifth root. You can leave it the way it is here, or you could factor out an a if you wanted to. Now, too bad the indices of the square roots, the third, the fourth, and the fifth root are not the same. Okay, another example. Reduce this or simplify this. You have the sixth root, you have the second root, and you assume that this is not a negative number. So what have I done? I can take out 6 of these as 1, I'm left with 1 of them. I can take out 3 of these and I'm left with 1 of them. So that, oh, too bad the indices are not the same. Okay. Could I make the third root of quantity to the power 1 the same as the sixth root of power 2? Yes, I certainly could. When I have sixth root, I can make that one fraction and the sixth root of that. And this is my numerator, this is my denominator under the radical sign. And then I can reduce this to 1 over quantity, and I can make it numerator, which is the sixth root of 1, which is just 1, and the denominator. Okay, we get another example. We want to rationalize this, which means have no root in the denominator. So multiply, I'm not sure why I need this. At this point, I don't need it because the cube root of a negative number is defined. So to rationalize this, I multiply numerator and denominator by the same quantity to the power 2, x plus 1 to the power 2, so that 3 of them can come out as a cube root. So quantity to the power 2, this comes out in the denominator, and the numerator I am stuck with the x and the second and the third root of quantity squared. Okay, exercises.